Hello and welcome to my channel. Today we're diving into the fascinating world of electrical interlocks, your ultimate safety and control mechanisms. Ever wondered how machines prevent dangerous operations automatically? That's the power of electrical interlocks. These invisible guardians ensure safety, precision, and reliability in industrial systems. Mastering the basics of interlocks is not just essential, but a key skill every electrical engineer must know. So, let's get started and unlock the potential of electrical interlocks. Okay, let's discuss the electrical interlock practically. An electrical interlock is a safety mechanism that prevents two devices from operating simultaneously when it could cause damage or unsafe conditions. In practice, this is achieved by using auxiliary contacts on relays or contactors to block the activation of other devices when one is already energized. This ensures a controlled, safe operation of equipment by preventing conflicting actions. This electrical control circuit demonstrates a simple but effective interlock mechanism using auxiliary contacts of contactors K1 and K2. The stop button acts as a master control, while the start buttons allow selective activation of the contactors. Electrical interlocks, like those shown here, are crucial for preventing unintended operations and ensuring safety in industrial systems. Mastering these concepts will help you design safe and efficient control circuits. If I summarize the whole circuit, K2 contactor would not energize unless K1 energizes. This contactor can be connected to any motor or VFD, or it could be used for different applications. Let's break this circuit down in a simple way so you can easily understand how interlocks work in this circuit. I have created some scenarios to provide more clarity for all the engineers, technicians, and my students. Scenario 1. If I want to start K2 by pressing Start PB2, will it start? No, it's not. Why? Because K1 must be running first. There's an interlock, a normally open contact of K1, that prevents K2 from activating until K1 is energized. Scenario 2. If I want to start K3 by pressing Start PB3, will it start? Again, no, it's not. That's because both K1 and K2 must already be running. Interlocks in K3's circuit make sure it won't activate out of sequence. Scenario 3. Now, if I press Start PB1, does K1 start? Yes, it does. This button directly energizes K1, provided there's no overload or stop condition. Scenario 4. What if I press Start PB2 after K1 is running? Will K2 start? Yes, it will. Why? Because now K1's interlock in K2's circuit has closed, allowing K2 to activate. Scenario 5. If I press Start PB3 after K2 is running, will K3 start? Yes. That's because the interlock from K2 has now cleared the way for K3 to energize. Scenario 6. What happens if I press Stop PB2 while K1, K2, and K3 are running? K2 and K3 stop. The stop button breaks K2's circuit, de-energizing it, and it also stops K3 as the K2 interlock is used there, but K1 remains unaffected. Scenario 7. What if I press Stop PB1 while both K1 and K2 are running? In this case, K1 stops and K2 also stops. That's because stopping K1 opens its interlock in K2's circuit, cutting power to both. Scenario 8. If K3's overload trips, does it affect K1 and K2? Nope. No, only K3 stops. Overload relays are independent for each contactor, so the other circuits continue running without issue. By now, you should see how interlocks act as safety guards, ensuring everything operates in the correct order. If this explanation helped, let me know your thoughts in the comments. And don't forget to like, share, and subscribe.